Now let us study the relationship between the EMF and PD. EMF, as you know, is the open circuit voltage. Now let me consider that the circuit is on and the current I is flowing in the circuit. When the current I is flowing in the circuit, in that case, whatever is the potential difference across this external resistance and the internal resistance of the cell, that we can write as E is equal to I into R plus I into R. Now in this case, the R is the external resistance which is connected here. So this is providing the potential difference across the external resistance as well as the internal resistance of the cell. As you know that internal resistance is present inside a cell and it will also produce a small potential difference. And let us consider small r as the internal resistance, which is shown here as small r. Now in this case, if I take I as common, then I can write as r plus r, and therefore I is equal to E upon r plus r. So this is the formula for the current flowing through a cell in a closed circuit. Here we are considering R as the external resistance and small r as the internal resistance, capital R as the external resistance. If I write this expression again, I will get I is equal to ER plus R. IR is equal to, here I into R can be written as V by using Ohm's law. V is equal to I into R. So for this we'll write this, V is equal to E minus I into R. So this is the formula which relates, or it is the relation between EMF, that is E, and PDV. V is equal to E minus I into R. This is the relation between EMF and PD. So I hope it is clear to you. Now if you consider the formula for current I is equal to E upon R plus R, then I can write here I into R is plus I into small r is equal to E, and therefore I into R is equal to E minus I into R, or small r is equal to E minus V upon I. Here I have written I into R as V. So small r, that is the internal resistance, can be written as E minus V upon I. Now this I can also be written as V by R, as you know from Ohm's law. So therefore R is equal to E minus V upon V by R. If I take the reciprocal, I will get R is equal to E minus V upon V into R. If I take the denominator as V and divide by both E and V, divide both E and V by V, then I will write this small r equal to E upon V minus 1 into R. So this is the expression for internal resistance of a cell. This is the expression which gives us the formula to find the internal resistance of the cell. R is equal to E upon V minus 1 into R. Now let us study the combination of cells in series and parallel. So let us first consider two cells connected in series. Let E1 and E2 and E2 be the two cells connected in series. Let small r1 and small r2 be their internal resistance. Now this formula is derived by you. We already have derived V is equal to E minus I into R. Using this, we will find out the equivalent EMF and equivalent resistance of two cells in series combination. That is, if you connect two cells in series, what is their internal resistance, equivalent internal resistance, and what is their equivalent EMF, that we have to find. So in this case, if we take R1 and R2 as the two resistances, then the current flowing through both will be same, because here in series combination the current remains the same. So I can write V1 as the PD across the first cell. V1 is equal to E minus I V1 is equal to E1 minus IR1, and V2 is equal to E2 minus IR2. I have taken I and not I1, I2 because the same current is passing through both the cells. So it is taken as I. And R1 and R2 are the resistances. They will produce a potential drop V1 and V2 given by these two formula. So what is the total potential? So that is V is equal to V1 plus V2. Now if I substitute the value, then I will get E1 minus IR1 plus this one E2 minus IR2. Then I can write E1 plus E2 and minus IR1 plus R2. Now this is the equivalent equivalent EMF minus I, and this will be the R equivalent. So V is equal to E equivalent minus I into R equivalent. So what is E equivalent? E equivalent is equal to E1 plus E2. So this is the equivalent EMF of two cells in series combination. And what is the equivalent resistance? This is equivalent EMF. What is equivalent resistance? So R equivalent is equal to R1 plus R2. This is the expression for